So here's an example. Okay, for clarity, I understand that TCP is, we've decided that TCP works with a rolling window, but for the clarity of this example, I'm just going to illustrate it so that all of the acknowledged packets have to run before the next one goes out. So this is an illustrative example that does not necessarily reflect reality. But here's what we do. So here's destination, and here's the source. So the link comes up. We start in slow start. We have one packet. One packet is released. Data. It goes to the destination. And the acknowledgement comes back. At this point, so I'll write the congestion window size down here. By the way, this is figure 3 in your notes. Congestion window size starts out as 1. Once this acknowledgement successfully arrives, what is the size of the congestion window? It's 2, doubles. Let's say the congestion threshold is 4. So at this point, I can send a data packet, and I can send another data packet immediately without waiting for it to be acknowledged. And these acknowledgements arrive here. Once the second acknowledgement successfully arrives, what's the size of my congestion window?
4.
It's 4. So now I can send 4 packets. And the acknowledgements come back. So once they all successfully arrive, what's the size of my congestion window? Now 5, because I went in slow start, I doubled. Now it's 4, that's the threshold, so now I increase by 1. And so on. So eventually it's inevitable, unless my network is already perfectly balanced, it's inevitable that the CW, the congestion window, will grow until congestion occurs. Maybe I should say, if congestion will occur eventually, then it's inevitable that we'll hit it by continually increasing the congestion window. It could be that I have a scenario where I'm actually uploading across my DSL line and then onto the gigabyte backbone, in which case it will never occur because the congestion balances out the other way. So in other words, now I have now I'm using an eyedropper to fill up the fire hose. So in that case, it's the reverse. Congestion will never occur in that scenario. So it's inevitable that the congestion window will grow until congestion occurs. How do we tell when congestion has occurred? Drop packet, which means no acknowledgement. How do we tell that an acknowledgement has not arrived?
Set a timer.
Timeout. That's right. So what we'll do is if a packet gets dropped by a router, obviously it won't arrive at the other end, and therefore the acknowledgement will not get back to us. So we set a timeout and wait until that timeout expires. Once that timeout expires, we declare the packet lost.
Are we getting acknowledgement for like each and every single packet we send?
Yes, should be acknowledgement for every packet.
Is that how it's used in practice, or just for?
I'm fairly sure that's how it's used in practice. Every single packet's acknowledged. Fairly sure that's.
Lost track.
Yeah.
How do we choose the threshold for the timer?
The timeout for I don't know. I'm assuming that's a parameter that can be chosen by the router. I'm not exactly sure. Like when the router advertises its services, I know that when TCP connections are set up, thresholds are advertised. So you could start out with an initial threshold that's declared by the router. So I'm assuming, I don't know this for sure, but I'm assuming that timeout can also be advertised. Yes.
Keep doubling for the first loss you have. After the first loss, and that's the threshold.
No, you don't. You always you keep doubling until you hit the threshold, and then.
No, I'm assuming that you don't have a threshold.
Oh, I see.
And then you keep doubling, and you lost. The first time you lose a packet, you know, half it, and that's your threshold. That's what I thought I read.
So in fact, what you do, you follow this procedure. So you double until you hit the threshold, then keep going. When you lose your first packet, you take whatever congestion window you have at that time, cut that in half, and that's your new congestion. Or excuse me, that's your new threshold. So, when congestion occurs, we have dropped packets. And what that means is no acknowledgements. So if I set a timeout, and once that expires, the packet is declared lost. And what happens at that point, once a packet is lost, the threshold is set to 1/2 the current congestion window size.
If you've passed like an initial threshold, so like if you've increased the congestion window by 1, then you lost packet. Does it make sense to increase it by half?
I can see where you keep dropping it. There's got to be a way for the congestion threshold to be increased again, but that's not. I don't know. There's got to be a way for the threshold to increase again. I didn't write that down.
Well, no, I mean, I'm not thinking about the threshold increasing because, like, let's say you already have a threshold, right?
Yes.
That's 4. And you're increasing the congestion window by 1 every time. And once you actually get a lost packet, it turns out that that's the answer to my question.
In fact, there's a minimum. So ordinarily, the threshold is set to 1/2 of the current window size. There's an advertised window that the next value of the threshold is I think, I can't remember if it's the minimum or the maximum between either that this value or the advertised